Okay, here we go. Alright, this is your stoichiometry test from yesterday. What we're going to do is I'm going to go through all the answers, and in this Edpuzzle video, you're going to click the right ones. So you're going to get your test back, and you're going to look through it, and if you get them right, just pick the same correct answer again. If you got it wrong, as I go through the problems, you're going to choose the correct answer, okay? And then you are getting a grade for this. So this is your test corrections, okay? All right, so number one, study of the quantity relationship between the reactants and products is the name of this test, okay? Hope you picked the answer. Number one should be pretty easy. Two, dimensional analysis. This is dimensional analysis, okay? When we cross something out. So like grams of beryllium gets canceled out, okay? We're not doing sig figs. We're not making a measurement. We're not graphing. We're converting between units. Third one, limiting reagent. In a completed chemical reaction will be the substance that is one of these two. I'm narrowing it down, either leftover or used up. Limiting, think back to our sandwiches. It's the one that we run out of first. Number four, what's the molar mass of ammonia carbonate? Okay, so to do this correctly, we have two nitrogens, which weigh 14. Multiply those together. Add it to hydrogen, 4 times 2, which there are 8 of, multiply it by 1.0. We have one carbon times the weight of 12, and then we also have 3 oxygens, okay? So add up 14, multiply, add them all up, pick the correct answer. Number 5, what's the number of moles of beryllium? We have 36 grams of beryllium. We divide by its molar mass, which is 9.0, okay? So when we do that, you get the correct answer. 36 divided by 9, choose the correct one. Number 6, in every chemical reaction, okay, we went through this yesterday, it was in the notes. They're saying what's conserved, what can't be changed. Masses change, volume can change. So what doesn't change ever, moles and our number of molecules. You cannot create nor destroy matter. All right, in the reaction, carbon monoxide plus oxygen gas makes carbon dioxide. What's our ratios of oxygen to moles of carbon dioxide? Here we have, look at your coefficients, 1 to 2. Number 8, how many moles of aluminum are needed to react completely with 12 moles of iron oxide? Okay, so we have 1.2, and we're in moles already. Okay, so we're just converting from moles of iron oxide to moles of our other reactant. Okay, so we have 1.2 moles of iron oxide. There are 3 and to 2. So 1.2 times 2 divided by 3. That'll be your answer. Choose the correct one. Number 9. The equation below shows the decomp of lead nitrate. How many grams of oxygen are produced when 11.5 grams of nitrate is formed? Okay. So we got 11.5 grams of NO2. We divide by its molar mass. Cancel out our grams. Okay. We then, second step, change it to moles. We look at our equation. For every 1 mole of oxygen, because that's what we want to change it to, we have 4 moles of NO2. Okay. And last step, the molar mass of oxygen is 32.0 grams. So 11.5 divided by 46. Multiply by 1, divide by 4, multiply by 32. Pick the correct answer. Number 10. How many grams of H3PO4 are produced when 10 moles of water react to form an excess of tetraphosphate decaoxygen? Okay, so we have 10 moles of water, and since we're in moles, we just use our numbers from our equation. For every 4 moles of H3PO4, we need 6 moles of water. Okay, so 10 times 4 divided by 6. That gets us moles of water. Now we got to change it to grams because we want it in grams. So then we look at the, we want grams of our product, P4O10. Molar mass is 98. 10 times 4 divided by 6 multiplied by 98. Choose the correct answer. Number 11. Which element has a molar mass of 30.974? They go in order. So just read across. There we are. 30.974. P. That's your answer. Choose the correct one. 12. What is the mass of 8 moles of sodium chloride? 8 moles. Okay. 1 mole of sodium chloride, if we look up the molar mass, weighs 58.5. Multiply these together. Choose the correct answer. How many molecules are in 3.6 grams of sodium chloride? Okay. For this, you need your chart. So we have mass to moles to molecules. So we're going to divide by our molar mass, and then we're going to multiply by 6.02 times 10 to the 23rd. 3.6 divided by its molar mass, 58.5. We found this on the previous page already. And then we multiply by 6.02. That gets us 0.370 times 10 to the 23rd. Okay? If we move our decimal point over one spot to be in scientific notation, we get 3.70 times 10 to the 22nd. Choose the correct answer. 14. How many grams are in 1.946 moles of sodium chloride? 1 mole weighs 58.5. That times that. Choose the correct answer. Number 15. What is true of the reactants shown below? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. I hope we get that one right. We're counting. 16. What is the correct mole ratio for K3PO4, potassium phosphate, to KNO3? 3 magnesiums. 3 magnesiums. 2 nitrogens. 3 times 2, 6 nitrogens. 6 nitrogens. Okay. Let's look at our actions. 3 times 2 is 6, times 3 is 18, plus 4 times 2. 4 times 2 is 8. 6 times 3 is also 18. Actions are balanced. Everything's good. Balanced equation. 3, 2, blank, 6. How many of these compared to how many of these? Choose the correct answer. 17. How many moles of copper are needed to react with 5.8 moles of AgNO3? 5.8 moles of AgNO3. That gives us, if we balance it out, cancels out with 2 moles of AgNO3 for every 1 mole of copper. 5.8 divided by 2. Choose the correct answer. How many grams of water will be produced if 750 grams of iron are produced? Balance your equation first. Okay? Might be hard to see this, but we have 1 iron oxide, O4, plus 4 H2s for every 3 irons plus 4 waters. Okay? 1, 4, 3, 4 are numbers needed to correctly balance. So we have 750 grams of iron divided by its molar mass, 55.8. Multiply by 4 moles of water, divide by 3 moles of iron, and multiply by its molar mass for water is 18.0 grams. Iron cancels out with our iron. 1 mole of iron cancels out with 3 moles of iron. 4 moles of water cancels out with 1 mole of water. 750 times 1 divided by 55.8 times by 4 divide by 3 multiply by 18.0 gets you the correct answer. Number 19, what type of reaction is this? Okay, we're just going to go through these, still select the right answer. We have a positive, a positive, and a negative, and they switched. K went with our negative, Our other positive went with our other negative. This is a double replacement. Calculate the percent yield for lead iodide. Okay? The weight of lead is 207.2, and there are 1 of those. The weight of iodine is 126.9. There are 2 of those. So here's our 2 weights. If we add them up, the total is 461. Okay? So 207.2 divided by the total, 453.8 divided by the total, gets us these 2 numbers. Both have 3 sig figs. To change it to a percent, decimal over 2 spots. This is 44.9%. This is 55.1%. Top one is our lead. Bottom one is our iodine. Balance our equation. 2 aluminums. Oop, maybe I did this wrong. Let's take a look here. 3 times 2 is 6 Fs. 3 times 2 is 6 Fs. 2 times 2 is 4 aluminums. Looks like we need a 4 here. 4 aluminums. Okay? So then we have 3 times 2 is 6 oxygens. 3 times 2 is 6 oxygens. 4 aluminums. Now we're all set. Even Mr. Huizenga messes up sometimes. We have 219 grams of aluminum fluoride. Okay? We're dividing it by its molar mass of 84 grams. That's what 1 mole of it weighs. Cancel out, cancel out. If we look at our equation, I need to change this to a 4. This is a 3. Okay? 3 F2s. This is our first one. So we're changing our aluminum fluoride to our moles of fluorine gas. Okay? 219 divided by 84 times 3 divided by 4. Okay? This is going to tell us the number of moles that we produce of fluorine gas with this much of aluminum fluoride. Now we're also going to do another problem. We're going to do 48 grams of oxygen gas. We're going to divide by 32. 48 times 1, divide by 32, times by 4, and then divide by 3. Okay? This is going to tell us how many moles of fluorine gas we have when we start with 48 grams of oxygen. Whichever one comes out with less, that'll tell you what the limiting reactant is. That's the one we're running out of first. So it's either going to be this guy or this guy. Which one are we running out of first? Whichever one we have extra of, okay, is going to be our excess reactant. To figure out how many grams of our extra reactant there are, okay, you take your moles and you subtract the 2. So whichever one's larger, subtract the smaller one. Okay? And then when you have the moles of it, simply change it to grams. Moles to grams. And that's your test. All done.